My name is Kevin Langston. I'm with the IBM Power Systems Academic Initiative, which provides free hardware and software resources to schools all over the world. And joining me in this presentation, who's really is going to cover most of what we're going to talk about today, is Kyle Pellet from Expel, to talk a little bit about data center security and some of the pitfalls and some of the things to consider when talking about cybersecurity and securing your network at that point. One of the things we like to do here, and we discussed this last night, is if you have a question during the presentation, feel free to jump in and ask it at the time we're covering that topic, and we'll try and get an answer to you or an explanation. If we can't get an explanation to you right away, we can always follow up with an email at a later time at that point. I wanted to start a little bit with the program that initiated all this relationship with Expel, or basically with Kyle Pellet prior to him joining Expel, in that we service a whole bunch of power system machines that provide this resource to schools all over the world. And one of our main issues that we had at the front end was SSH brute force attacks to our systems. And as it came about, we hooked up with a school called Prelude at that time to have some students do a capstone project to cover the current issues that we were facing with our public-facing network and come up with a determination of how to mitigate it. The research for this took about 2 months, and tools that were used for QRadar and some other source tools, which identified where the attacks were coming from, and to the extent of what the strategy was against these attacks. Ultimately, Kyle and his team came up with a solution topology for implementing some security against these sorts of things at that point. We have quite a large resource in that data center with about 3,000 cores in the power systems and a couple petabytes of SAN storage that we deal with. And currently, there's about 800 schools in the program on every continent. So it's critical to us to be able to provide this service without interference at the front end, which is why we're public facing at that point. Make it easier for us to interface with all of the different university, college, and absolutely some high schools in the way they implement security at their local networks at that point. So if you think I've talked enough, I might turn this over to Kyle here. One thing I would like to say, we didn't put our email addresses up there. If you have any questions, be sure and ask them during the presentation, and we'll try and get our emails up there to you so that you can contact us at a later date if you have any more questions at that point. So I think without any further interruption by me, I'm going to turn this over to Kyle Pellet from Expel and let him explain his presentation at this point.
Great. Thank you, Kevin. Yeah, I do have my email here. Feel free to email me. This is my business email. I work for Expel, and if you don't know what a SOC is, it's a Security Operations Center. Expel provides SOC as a services to a number of customers. The idea behind it is companies either don't want to pay or don't have enough resources to hire and train and maintain a security operations center. They actually outsource it to us. The goal of this presentation is really to just tell you what we see, what I see in the SOC, and try to explain the prevalence of it, how frequent it happens, what we're looking for. I couldn't possibly go into every single detection and tell you how they all work and all that in the amount of time we have. But what I can do is go through and tell you what we see the most, what I think is the most pertinent to data centers and really all businesses. So yeah, if you feel like you want to ask me a question through email, that's fine. Otherwise, I'm going to take a peek at the chat and I'll try to catch your questions, or you can turn your microphone on if you so choose. All right, so what we're going to cover, I like to start with, when I was putting this presentation together, I was thinking, what's a good way to show like a metric? And I was thinking money. So this is an FBI crime report. If you notice, these things that have squares around them is really what the three things I'm going to zone in on, and their relationship to the amount of loss, right? It's unfortunate that these numbers aren't truly representative of like reality, because think about it, these are FBI involved cases where they've actually been able to determine that these are losses and attribute these to these different things, right? These different categories, crime types. So the one at the top you might notice is huge. It's 1.7 billion, and it's BEC, which stands for Business Email Compromise. We see that a lot. That's probably a daily occurrence for us at Expel. And EAC is just email account compromise, same idea. We'll also talk about malware and scareware, mostly malware. Again, that's another sprawling category that could take hours to cover just one malware like effectively from start to finish, but we're going to do a quick rundown on that. And phishing, smishing, farming. So really just phishing and all of its subcategories. We'll talk a little bit about detection and response, how we detect these things, what we do to mitigate them, make the companies more resilient to them. And then we can talk a little bit about as well the having defined roles in your company. It's pretty important to have people, if you have the resources, dedicated to security. It's really hard to have security as a full-time job and also be a sysadmin or anything else there. And at the end of it, I want to give you guys resources to stay in the loop on how you can further protect yourselves. There's frameworks to follow. NIST has just released a new one last week. Move on. So yeah, attackers they're smart people, frankly. They do this for money. So they're not going to be just willy-nilly out there registering domains. And I like this graph because this shows in a 1 month period, right? We have this graph flattened out at 0. And these are just specific to coronavirus, meaning the websites have the word corona or COVID in the domain, or there's a file with the name corona. These are people taking advantage of current events in a 1 month span to go from 0 to over 5,000. So they're opportunistic, right? That's all I'm trying to say there. It's really interesting to me how you can use people's fear against them in a way and make money off of it, and people are going to do that. This one on the bottom, I want us to point out that BEC has been effectively doubling every year as far as the amount of money that the FBI is saying it's costing businesses. All of these pictures are going to have links, so if you want to download the slides later, you can follow up right with the picture. And there's no indication this is slowing down. So this is why this is the biggest thing I want to talk about, BEC. But first, let's talk about phishing, because you almost can't have BEC without phishing. That's not true, but they almost go hand in hand. So the definition, if you don't know, is the fraudulent practice of sending emails purporting to be from reputable companies in order to introduce individuals to reveal personal information such as passwords and credit card numbers. So if you don't know, this is an attacker and your victim. Attacker sends an email to the victim. It's a malicious email. Often the victim will click on the email and say, oh, this looks legit. The National Security Department wants me to FaceTime with them. So I'm going to click on this link. Oh, but to do that, it wants me to log into some credential page, say Gmail or even like a single sign-on like Okta, anything that the attacker's designed, right? The attacker made this phishing website and controls it, so they can also see all of the credentials and other inputs that the victim, such as like what device they're using. They can actually get a lot of information out of somebody just browsing to the page they own. And then they can pass the credentials on to a legitimate website, right? And so this is phishing. It's really the most common tactic, even for red teams. If you hire like folks to pretend to be attackers in your environment, 9 times out of 10 they're going to start with phishing your employees to try to get initial access. People like to pretend they're Microsoft and Amazon, among other things. In fact, 1 in 25 of them are going to say, "Hey, this is a legitimate Microsoft email." This one even says it right here: Apple FaceTime information disclosure. So the psychology behind it is really, we need to make, if you're an attacker, you're going to want to produce a sense of urgency. Like, hey, you need to do this thing right now because it's important. And they'll try to scare you often, but let's move on sometimes. Yeah, so why is it so effective? And why is it still a thing, right? The phishing has been around forever. And the bottom line is it costs attackers nothing. The conversion rate, if you want to think about it from business terms, is very low. They might send out millions of phishing emails a day or an hour, who knows, depending on the size of the attacker's infrastructure. And they might get 0.001%, but it's still worth it for them to continue to send those phishing emails because it costs them effectively nothing. I was hinting on this earlier. If you hire someone to do a penetration test, it's going to involve, I put it in purple because it's really about your red team and your blue team defending from the red team. So the fake attackers are red, will, like I said, often try to phish you to establish an initial foothold. This chart is just if you think about it, the attack spectrum, right? There's going to be really broad phishing and there's going to be really targeted phishing. And this is where you get into spear phishing. You may have heard that term. Arguably more devastating and destructive than regular old broad phishing, which is just going to be scams and Nigerian princes and whatever, IRS. But a spear phishing attack is going to be more targeted, meaning it's going to have more personal information. The attackers probably have done a little more research to know who they're sending the email to. It's not going to be sent to as many people, maybe only one person. And this is really where the scary from a business perspective cost comes from, right? The business impact is much larger here, represented by these dollar signs. This is okay, so now that we've kind of talked about how phishing works, let's talk about how it actually, like the technicalities and things that are really maybe not known to you. Puny code. So the long and short of this is you can use different letters, different characters from other languages that appear to be, like, for example, this P in Apple is not an actual, P on your keyboard. This is some Cyrillic alphabet that looks like a lower P, right? Lowercase p. You can use a translator. You can copy this to a text editor and paste it in, and it'll often do this. It'll show you that this is actually an encoded string. This Apple looks like this. This PayPal looks like this. We can talk about little endian encoding later. You can look that up. I think there's actually a reference in this wolfandco.com that'll speak to how this works and why it works. But you need to walk away from this remembering that even if you look at the domain or the sender for that email and it says apple.com, it might not really be apple.com. The more common one that you're probably aware of is typo squatting, which is kind of like two aspects to this. Either the attacker is hoping somebody types in Google wrong, right? Say they type Guoogle. They might have registered that domain, and they'll make a website that looks like Google, but it won't be, right? It'll be attacker owned. The other thing is you can send people emails from apple.om, right? Somebody might say like, oh, Apple, and in their brain they're thinking, they might just not register. There's a missing C on this example right here. But yeah, this is like really granular ways that typo squatting works, but it's based on the name. It's preying on typos. And this is common. In fact, it's so common, it's in almost all BEC attacks. So the reason I talked about phishing first is because I recommended that, or I was going over the slides, and I was like, I really want to start with BEC, but this slide might not make as much sense if we didn't go over that. All this is saying is there's three different techniques in the graphics here that attackers use, and 81% of them, I wanted to call this out, is this display name deception. So if you're just playing by the numbers, you might think this is more important, which it probably is. But this is also the easiest one, right? So this might be the biggest on this pie chart here, but the targeted attacks are going to be more like this. These spoofing and lookalike domains. The display name deception is actually the least, from my experience, least costly when it does go off, because it's probably just not as going to be as targeted and effective. And we talked about this a little bit. To pull off one of these spoofing and lookalike domain attacks, these lower percentage frequency but higher impact generally, you're going to have to know a little bit more about your target. And really you're going to have to do a lot of homework. You're going to have to register weird domains that you've either typo squatted or puny coded or just created, or just happen to get lucky. Sometimes businesses just forget to re-register their domains. I don't want to call anyone out, but it has happened, and when it does, the person that's lucky enough to register that domain, such as google.com, makes $1 million overnight or more. So, but yeah, let's move on. So, business email compromise often results in something like this. The CEO, right? The CEO gets phished, and they start sending like, "Hey, I'm going to need you to send me $250,000 right now. It's important. I'm at a meeting in Taiwan. I need this money right now." And then somebody in finance will be like, "Oh, the CEO wants me to do something. I better jump and do this right now." But the other thing they might do, say that they, instead of getting the CEO right away with a phishing attack, they might send a credential harvesting phish to everybody in their environment. So let's reverse this. Let's say that the finance person, better yet, the new intern got phished, right? The attacker might notice, hey, I don't seem to have as much power, right? Like you can tell this person's Facebook and LinkedIn page, they don't seem to be in the C-suite. So they're going to try to elevate their privileges up to something where they can actually pull off a BEC attack. But what they're probably going to do is they're going to send internally to all of that intern's contacts an email that looks like something like this, right? Hey, can you help me with this thing, right? And then somebody will open it up and they'll be presented with a page that looks pretty legit, right? You might notice it says not secure up here and the domain might not be legit. But by and large, this looks like pretty standard Windows background with a login page. The attacker created this. This isn't real. As soon as you enter your credentials here, the attacker who's in control of the intern's account now has your credentials, right? And this works surprisingly well. You might not think it does, but the numbers always surprise companies that pay for testing to find out. So what we do at Expel daily is we look for these BEC detections, right? That example where the intern got compromised and sent phishing emails out to try to capture another account to make money off of somehow, maybe sending invoices, doing whatever. Come to find out there's about 8 things, at least enough, that happen often enough to list them on this slide. You might notice when that intern account gets created, they're going to make an inbox rule that automatically forwards to hidden folders. They might make hidden folders, right? All these things. They might make a rule that automatically deletes messages. This is like a telltale one that happens almost every single time. You can always tell whenever there's an inbox rule that's named like period, that's designed to delete all messages containing, the words, statement outstanding, past due, payment, invoice, wire. That's highly suspicious. That's something you're going to want to look at. And there's more. There's delegations, there's logins from VPN services that are unusual or infrequent for the user. Forwarding to external Gmail from your business account, pretty suspicious. Or at least maybe against your company's policy. But down here on this bottom half of the slide, I wanted to point out, this is what it looks like. This is what we're going to see if you're a defender, if you're actually looking for these things, this BEC, or business email compromise. You might notice somebody's making a rule that everything sent to the CEO is going to redirect to, whatever at gmail.com. And furthermore, if the subject or body contains these words. So, excuse me, the attacker will send out to everyone on the CEO, let's pretend the CEO is compromised for this one. He's going to go down his mailing list. He's going to send a subject for, hey, I have an outstanding invoice. I need you to wire me, blah, blah, blah. And they're going to redirect everything that comes in. So when somebody responds to that and says, like, is this real? Like, you're sitting in the conference room next to me right now. Like, what's going on? They're not going to see it. The CEO, the actual CEO, not the attacker controlling it, isn't going to know that they're compromised. And they're just going to spew out all these emails to everybody until something works. Which happens. It's amazing. Until you start looking for this stuff, you don't realize that somebody's spamming your entire company. Here's some pretty quick slide. If you don't have MFA, MFA stands for multi-factor authentication. And then here's some examples like Duo, Google Authenticator, LastPass. This is the number one thing because it makes it harder for the attackers. So if you don't have MFA because your company's too large or you can't afford it, that's okay. But you can still encourage your individuals to enable it, right? Even if it's not a company-wide policy, this just makes it harder. It's not unbeatable. Attackers can do man-in-the-middle attacks where they pretend to be your multi-factor or your two-factor authenticator, but it's oftentimes just enabling that is enough to kind of dissuade them from even trying. And then if you don't, this is why when it comes to money, this is a lot of things to do. You're constantly monitoring logins from and geolocating them to determine if there's like geo infeasibility. Hey, how can you log in from Santa Barbara and Tucson in 20 seconds, right? Like you can't travel that fast, right? So, but you can write detections and rules and blah blah blah. But the common BEC tactics, like those 8 things we saw, making new inbox rules, forwarding to outside addresses, making new folders even sometimes. And then really, I can't speak to the effectiveness of this, but if you are going to do a wire transfer, make sure somebody else has talked to you on the phone, or better yet, have a paper trail. Okay,
Hey,
we're breezing
Kyle?
along. Oh, go ahead. Somebody have a question?
Yeah, this is Kevin. Without revealing a company or an individual, could you give us an example of something you've experienced along the way to the BEC strength?
Yeah, so without revealing a company, yesterday, in fact, last night about 8 p.m., we had somebody who has a PAN firewall, which is a brand of firewall, and we noticed somebody from a Russian IP address logging into the PAN console at an elevated privilege using somebody's cookie. And we're like, oh, that's weird, because this person's in California, always logs in California, but we saw out of nowhere Pakistan, and the successful one was Russia. So we're like, okay, this is bizarre. And the credential wasn't username and password. This may be a little more complicated, but it's the most recent one that popped in my head. Anyway, we traced it back to that example I was speaking of where the user had clicked on an email from a trusted source, which happened to be like their IT or their DevOps engineer sent an email saying, hey, everybody, please update your Google Chrome browser, right? There's this new crazy attack, right? There's this ODay, this very scary thing that you're going to need to download this patch. And I think it came out later that it went to a bunch of people's spam boxes, but it didn't go to this guy's, and he clicked on it, and he actually had given the attacker who had compromised the DevOps engineer's account access into his box, more or less, right? It was able to download his cached history in Google Chrome, all of his cookies, all of his browser history, all of his credentials he had stored in Google Chrome. When you log into your account, it's like Google Chrome already has seen you, and it knows who you are. It has everything cached and saved. The attacker got that in a matter of 20 seconds from an email sent from his IT department. So it's pretty believable or, understandable that could happen if you thought that original email was legitimate. Does that make sense? I know it's like
Yeah.
three different actors, right? You have your IT department sending, who's compromised, sending an email to another employee. That person clicked on it. The result was he lost all his passwords that he had stored in Chrome.
No, that makes sense. Thank you.
Okay, yeah. Which, by the way, is a real big problem because it's really hard to remember all of your accounts that you had stored in Google Chrome. So he's probably spending all day today going back and resetting credentials, looking for anything weird. If he ever logged into his bank from that device, he might, every account he has is a problem for him right now. So that's kind of the impact of it. And a lot of the times he might miss somebody. He might miss one of those accounts. Say, I don't know, Skype or something. Something that seems benign. He might be like, yeah, I never use that anyway. But the attacker has his creds. So if he shares that password, which is possible, now the attacker can go back, put it on some list, put it into a script that's going to try that password and that username on everything else. Maybe his mortgage site or whatever, some kind of financial institution, TurboTax, who knows. And chances are, if he reshares his password, he's going to have an attacker in his accounts for the rest of his life, right? Until he tries to put a stop to that. Excuse me. So we talked about the mitigation and resilience, and yeah, this is just a general food for thought. The other one that's not on here is if you don't have somebody looking at your monitoring geolocation records, you don't have somebody looking at your endpoint detection agents. You're not going to have somebody monitoring your network firewall probably. And it really, depending on the size of your company, is a full-time job to not only stay up to date with all of the updates and understanding why new detections are passed, why PAN has decided that all of a sudden, api.googletask.com is malicious. You're not going to know. It's going to look benign to you and if you don't actually stay up to date with what's happening. And it happens so fast, right? All of a sudden, there was an O-Day 2 weeks ago, the zero logon. I think there's a link to it at the end. All of a sudden, anybody can authenticate to LSAS for just by sending blank packets back and forth, or something along those lines. Anyway, I mentioned earlier, or maybe I didn't, but it was in the slides, that phishing emails often contain documents, and almost always they're PDFs or they're Excel spreadsheets or they're Windows, Microsoft Word documents, and they'll contain some kind of macro, right? And these macros or even links to other websites are going to happen when you open up the document. But oftentimes it's also just straight up malware. It's just here's a Windows binary. When you run it, it'll do something like this. You'll execute that binary, say it's a PDF or pretending to be a PDF. It'll execute a PowerShell script in the background the user won't know, and it'll run through all of these tasks. It'll establish persistence, so it's going to run at a time controlled by the attacker. And pretty much once you hit execute, eventually you're going to end up in this bad spot where all of this happens. We can try to get into it if we have time later, if somebody wants to hear about like a really specific example. But at the end of the day, you're going to have command and control, meaning that machine is going to beacon out or send packets over the wire, over the internet to the attacker. And the attacker is going to be able to issue commands back to that computer. So I wanted to come back here for a second. This is, according to the FBI, much lower impact than BEC because it's almost like this is a little bit more under control. But then you hear about devastating ransomware, crypto mining. Nobody even knows how many crypto miners are out there. There's remote access Trojans. There's potentially unwanted programs that end up being just adware. So it's like this huge slew of different, if you really get into all the different types and families, it's outstanding how diverse they really are. But I wanted to show this slide again. I know I'm hanging on this one. If you look from left to right, initial access, right? We talked about phishing is a really big one. There's also remote desktop brute forcing. People just sit there, and hammer away at your RDP, like at that data center that I worked with Kevin. They just had constant SSH brute force attacks from everywhere. So if you have vulnerable internet-facing systems, like say you have really weak passwords and you have no password attempt timeouts, or you have very weak passwords, whatever. You have unupdated passwords where the patches, there's known Metasploit kits out there that are just exploits. All you have to do is press 2 buttons and that exploit's you're able to execute code on that internet-facing system. Okay, so each one of these steps has to happen before the preceding one. But they always kind of end up going like this. You have some amount of initial access. You have a credential theft. So these are the different ways that attackers do that. And then you have lateral movement. Typically, once you get credentials on one machine, you kind of want to explore the environment. You want to do some reconnaissance. But then eventually you need to move, right? You want to go establish persistence somewhere else. And persistence, I want to talk about this shadow IT tools. It's amazing to me how much this really goes on. People just willy-nilly download uTorrent and then they just go and pirate Photoshop or whatever. They just go and get something that you're like, why do you have this on your machine? Why are you doing this? But a lot of people just don't understand that it's not trustworthy. If the thing's free, you're really the product, right? There's no such thing as free, especially when it comes to software that you're downloading. So I just wanted to stress that there needs to be some amount of training and awareness about security. You don't have to be a pro. You don't have to understand this slide. It really, between you and me, like until you have to interface with this, all you need to know is it's bad, right? You need to be able to spot bad. You need to know not to install malicious software. I really wanted to talk about remote access Trojans. This is my favorite. I think the capability of these things is outstanding. There's at the end, there's going to be a resources tab with a bunch of links, and these just make for the best reads to me. So what it looks like from the attacker's point of view is this orange screenshot here, and I just listed just under this one tab. This is all you can browse the file manager. Remember, these are attacked computers, right? These are compromised computers. This Ricky Bobby PC has this remote access agent on it, and the agent's beaconing back out. And from the attacker's computer, they're able to do this. They're able to issue these commands to them. You can browse their file manager. So while they're at work, you can be opening My Documents, checking out their downloads. You can drop files there. You can pull files out. They can delete your processes. Say you're trying to Google, like, how do I fix this problem with my computer? Like, I can see my mouse moving around and blah, blah, blah. They can kill your Google Chrome session. They can straight up take control of your computer. They can remote desktop in. So where they're in control and the attacker is in control and the victim just has to watch as they click around and do whatever they want to do. A big one you might have heard of, they can turn on your camera. They can even turn the little light off that indicates your camera's on, but have the camera on. Spawn a shell. They can get into your registry. They can record all your strokes, your keystrokes, and ship the logs back so they can later go through and be like, what happens when they type in the first 6 minutes they've logged in? And they can go see pretty much generally all your passwords are stored in that amount of time, or they can just get your passwords out of memory. So anyway, the list goes on. I wasn't sure if anyone else was going to be aware of what this was, the capabilities of remote access Trojans, but I always find it fascinating. I don't know how we are on time, but this slide is just illustrating what a botnet is, because crime as a service you might not have heard of. People can actually pay for other people's infected machines, right? And that's called a botnet. So if you look at this number one, we have this guy in red. He's sending this Trojan, or this virus, over to these black computers, and this guy is smiling over here. He's a happy, unknowing user. And then 2 establishes persistence, right? Gets that initial foothold, laterally moves, establishes persistence. So at any time, red can press a button over here and control what these black machines are doing. And then introduce Gray. Gray is a customer of the crime, right? He's paying Red money for this outcome, where I guess they're sending spam. So yeah, then the attack goes through, right? So they're both happy over here, and the victim in black over here is very, very upset that his computers are spewing spam. This is more prevalent than you might think. A lot of people don't have time to sit around and learn how to deploy Trojans, and they'd rather just pay the money for the service. There's marketplaces. I don't think I can name them or give them away, but you can go find out if you really want how to pay for botnet services. With botnets, you can do a lot of it's for marketing, for being honest, or delivering ads, malicious ads probably. But if you write some new swanky malware and all you need to do is deliver it, you can go pay someone else to deliver it for you. Right. And then this down here, this is another generalization, I believe. Guy did a 9-month study in 2018, so quite some time ago. And this is the amount. I think a credit card goes for like $500 maybe on the dark web, Silk Road or whatever. But a credit card with a billing address, and a credit goes for a little more. A credit card with billing address, shipping address, I don't know, social security number, whatever. The more information you have about somebody, the more value it has. And this is just, I recommend going to this Turns Out Crime Does Pay site if you're curious. You might notice that crimeware and crime as a service is only 1.6, whereas data trading, IPO theft, illegal markets is much larger. But to me, 1.6 billion is still a lot. That means that this guy in red's making 1.6 billion. Generally, this is one individual that operates one of these things. Well, it may be more than one individual, but one entity of botnet makes this much, 1.6 billion, which I thought was interesting. People that author malware and deliver malware, they're up there too. So it's lucrative, right? And here's just when I was making this slide, when I was making this presentation, this is where I started. I wanted to talk about all of these different things, and then as I have all these interesting topics on attackers, right? Somebody executing Slack code, or through Slack executing code on your box, or Slack is it's a messaging app. Attacks in cloud and Azure and AWS, GCP. I really wanted to get into that. That's one thing Expel does. Crypto mining. Unfortunately, I don't think we have time to get into those. And then I have some statistics. There's some mitigations over here. Statistics is really just like if you want to look at graphs and charts. Mitigation, I have links to like Expel's phishing service. That's a new service that Expel, the company I work for, has launched, where they'll actually do your phishing investigation for you. So if you have a company that's saying, hey, we don't have anybody to actually go over this stuff, but we need somebody to do that, Expel does that now. Also, AWS, there's some pretty key standards that you should be abiding by if you're an AWS shop. And there's even more protection here, prevention. Kubernetes is a up and coming attack vector, where attack vector meaning that attackers are starting to target that to get after you. So if you don't understand how that works from a security standpoint, this is a pretty good Microsoft blog on that. Same with GCP. And then again, if you're not abiding by a framework or a security mentality, NIST is a pretty good way to check all the boxes and actually get something out of it if you take it seriously from a company perspective. And then if you're into RSS feeds, here's a good one, and the top 25 people to follow on Twitter that I just recommended. Okay, I think we have some notice and disclaimers here. Okay.
So we have about 7 minutes left here in this presentation. If anyone has any questions, feel free to launch at this point.
If that's okay, if we don't have any questions, we can go into.
I got a question.
Okay, go ahead.
I got a couple questions. So the example that you gave earlier in the presentation about the business email compromise that you detected from Pakistan or Russia,
Yeah.
at what point did your service kick in and provide any value for that company that was attacked?
Sure. Yeah. So the moment that it happened, we I think I can show you what it looks like from our perspective, but we get a little box and it says, "Hey, this is an alert," right? And it came into our we prioritize them by high, medium, low. This was a high alert, so it kind of it grabs your attention because not a lot of things do so. The quick answer to your question is within minutes. We were in the company's. We communicate through Slack. Say, hey, you have a compromised account logging in from Russia, which is unusual for them. I think from start to finish, it was like a 2-hour process till we were like wrapped up with our investigation. But for our initial warning, like, hey, you need to do something about this. We need to escalate to your IT team to take care of that. It was under 10, which is pretty quick.
Okay. Okay.
Um,
And then my
you go.
and then my other question, if you could go back to your you had I think it was a ransomware execution graphic with
Yes.
PowerShell. Yep. So I've been understanding a little bit that a lot of ransomware does get executed with PowerShell. Is it realistic that an endpoint that we can disable PowerShell on an endpoint, or is that maybe a scripting or a service that's used by Microsoft for like updates or anything? Is that realistic to even disable that?
Yeah, it's an interesting point. Generally, no. It turns out that PowerShell is used legitimately, and if you look into your Windows logs, you might say like, hey, PowerShell always looks suspicious. It's because it is. It's always looks weird, but you can't just go ahead and nix it from. You can't disable it, unfortunately, unless you don't expect your systems to perform as Windows intended. But what
Right.
you can do is you can limit the ways that PowerShell interacts with applications, right? You can say, hey, if PowerShell is doing X number of other things, we want to stop that, right? We could also turn off executing. I wish I had a better answer for specifically what you can do, but to answer your question, no, you're going to need PowerShell
Gotcha. Okay.
generally.
Thanks. Good presentation, and I really thought it was informative.
Great, yeah, thanks. Any other questions? We can talk about this slide some more. So let's start at the beginning again. This execution, and then you have this PowerShell script. PowerShell script could be anything. It could be like a command shell script. It could be a bash script. It doesn't actually matter what the script was written in. It's the code in the script that's really a problem. PowerShell just so happens to be like pretty easy to hide, and it came into vogue or it became popular again recently, but it's kind of dying out again. People like to use like VBS scripts or other. I mean, I shouldn't generalize it like that. Of course, there's still bad PowerShell. Of course, there's still bad everything out there, but you can kind of see it come and go in waves.
Recording.
Was that a question or was that Blue Jeans?
No, that was that was Blue Jean.
Okay. How are we doing on time here? I can blab about this slide for some more if you like.
Yeah, we only have about a minute left, Kevin.
Okay. Well, anyway, thanks for your time, everybody. Again, if you have any questions, I'll refer back to this slide with my email on it. This is my name at expel.io. Also, go check out our site if you want to learn more. This might be a good option for you or your company. There's tons of other vendor technologies, network and endpoint. One nice thing about Expel is we'll integrate with what you already have. We don't make you stop what you have and do something else. And we integrate with dozens of technologies.
All right. Well, thank you everyone for attending. And Kyle, excellent job. Thank you again.
Yes, thank you, Kyle.